Hey folks, welcome to the video here. Today what we're talking about are organic compounds, and so the first thing we're going to do is we're just going to go through a document that you'll find on your data booklet, or in your data booklet, sorry. And basically this is going to give you a lot of information, help you out. So the first section that you'll notice are what we call alkanes, and so notice the ending ANE. Here it's underlined on this slide. That means that it's ANE if there is a single bond between your carbons of your hydrocarbon. So hydrogen and carbon bonded together. Between the carbon chain, a single bond represents an alkane, ANE. Notice this one is ENE, it's an alkene, but this bond here is a double bond, if you can see that. So there's two, so the bond essentially would look like this. Okay, and the last one is an alkyne, or an alkyne, and so it's YNE if the bond at the end is triple. So it'd look like this: 1, 2, 3. Okay, so those are your hydrocarbons. I'll call them HCs. The next one though is an alcohol. And so you literally in this section, you get a ton of information just from your data booklet. So the R group is just representing your carbon group, but this OH, sometimes you might see it like this bonded, it has a hydroxide coming off the end. So now what you're going to notice with that, it's going to be an alcohol, and it's going to have OL at the end. So in this case, this diagram here has 1, 2 carbons, and we'll talk a little bit about this as we move on, but there's a table of alkanes, and basically what's going to happen is if it has 2 C's, we're going to call it ethane, and if it has the OH attached, we're going to change the ending to OL, so that's why you would see this written as ethanol. Okay. So the next type we have to talk about right here is the carboxylic acid. Okay, so notice that we have a carbon group attached to a carbon double bonded to an oxygen and then attached to a hydroxide, so this O and this H. So you'll notice that actually circled here, you'll have 2 carbons, which is again F. Okay, and now that double bonded oxygen here and that OH, so when you see that structure, you know it is a carboxylic acid, and so this one would be, instead of ethane, it's going to be ethanoic acid. Okay, and in a different video we'll talk a little bit about some examples and some properties and characteristics of each of these. So now the next one is a little trickier. Sometimes this gives people problems, but it is an ester. Okay, so this is essentially what, in order to get an ester, or the esterification reaction, which is what this is showing, is if we take an acid plus an alcohol, we're going to get an ester and water. So what's happening here is you can see the structure of the ester right here. Okay, so now this has lost its H here. Okay, it's OH, and this one has lost its H, and so these are going to become H2O. So in the middle here, this used to be a double bonded, so this was your acid and this was your alcohol. So we lose the OH here, lose the H, and then what we get is HOH, which is left over, is going to make your water right here. And so the side with the double bonded oxygen becomes your parent chain, and this circle becomes your branch. Okay, so, and this would be your alcohol here, this would be your acid. So that's your acid, and that's your alcohol. Okay, so, and these esters are going to be used for flavoring and smells and things like that, but We'll show you a trick in class that'll help you with that. Okay, so the next one is just a halogenated hydrocarbon. So notice that down at the bottom, so this talks about the carbon group. This represents a different carbon group, but this Q represents the halogens. And notice that down here, there is fluoro, chloro, bromo, and iodo. Now that is going to be how we name these halogenated hydrocarbons. And notice they are all in group 17 on your periodic table, okay? So what happens here is we're going to have a hydrocarbon, and just notice right here circled, we have chlorine attached to it. So that's going to be a halogenated hydrocarbon, okay? So how do you recognize it? Well, one of these down here. So this would be F, that would be Cl, that would be Br, that would be I. Okay, so when you recognize those symbols attached to a hydrocarbon, then you know it's a halogenated hydrocarbon. So it shows an example of how it's written over here. So chloral ethane. So the prefix for how it's written, okay, is actually going to be written first. So in this case, it's chloro and ethane. And if it was located on specific carbons, we would have to add that as well. The last one is a polymer, but we don't need to know that for the diploma. Okay, so hopefully that helps a little bit. So just moving on, basically just talking about structure, just a little bit you should know from Science 20 or Chem 20 if you've taken those, which you should have. But the difference between alkanes, alkenes, and alkynes, okay? And so just remember the bonds are different, and you can see in the images here if you wanted to pause and read that. So in your data booklet, you're also going to have this, this diagram here. So now what you're going to see is this table of alkanes. So these 1, 2, 3, these numbers with the C, that represents your carbons. So when we name or write, we want to find the longest carbon chain, but the longest carbon chain is the carbons in sequence. So if I had 4 carbons in a row, then I would be using bute. If I had 6, I would be using hex. So in alkanes, they would be hexane or butane, and they would just have hydrogens attached to them. But sometimes we have halogenated hydrocarbons. Sometimes we have carboxylic acids, but we still use the beginning of this name, like methanoic acid, ethanoic acid, methanol, ethanol, right? So we can use this to help us out with the naming of specific organic compounds. Now also here you should know these 10 prefixes. If you don't, it's also in your data booklet, but I'd really like you to know that. I'd also really like you to know the 10 alkanes. Okay. So moving on yet again. So just a review on naming hydrocarbons. Again, we don't have to worry about branches in this class, even though this shows that there are branches. You don't have to worry about them. So we will first take a look. So the first thing you're going to do is you're going to circle the parent chain, just like we did here. Circle the parent chain. Now, notice that the double bond is closest to the left, so we would start numbering from the left. So this would be carbon 1, 2, and this one would be 3, 4, and this one would be 5. Okay? And so now when we actually name it, we would put squares around any branches, or for example, if there was an OH, a hydroxyl listed on it, or if there was a halide that was attached to it, like chlorine, bromine, or bromide, or iodide, okay, for example, then we would have to now put a square around those. But we circle the longest carbon chain. If there's a double or triple bond, we start on the side closest, where the double bond or triple bond is closest to, and we number our carbons. Okay? And so the next thing that we're going to do is now that we have that, we can actually name it. So if we have our 1, 2, 3, 4, 5, then what we can do is we know that 5, based on our previous chart, or chart of alkanes, 5 carbons is going to be pentane. And now what's different here is that this has a double bond. So now that ending has to change to -ene. So now it's actually pentene. Okay, but where after which carbon is the bond located? So the bond is located here after the second carbon. So this would be 2-pentene. Okay, if you take a look up here though, we're not going to add the branches in, but the branches would be listed first. But in this case, the pentene, notice that it's also written up here, pent-2-ene can be written that way as well if you'd like. So benzene rings as well. So if you take a look at these structural diagrams, so benzene ring is actually going to be a hexagonal shape. There's different ways you can draw it. So you need to understand all these different ways. Way 1, 2, 3. Notice this is a hexagonal shape and it has a circle in the inside. This one shows where there are double bonds, okay, on each side. Now, it is also acceptable to move the bonds over here and draw it as such, okay? You can also do that, but you need to be able to draw benzene. For your quizzes, you need to be able to recognize a benzene or a benzenated compound. So remember, benzene is a carcinogen, so it can cause cancer, but it's in a lot of substances, so aromatics and such. Its structure is C6H6. So there's 6 carbons and 6 hydrogens bonded together, and you can really see that in this diagram here. But the thing is that benzene's very stable, and therefore it's a very persistent organic pollutant. So it stays in the environment for a long time. So benzenated compounds are actually not very, or they're actually detrimental to the health of the environment. But what happens is they're so stable, they stick around for a long time. But we can get different types of substances bonding to these benzene compounds. And if we have a benzenated compound, then we have some environmental problems. But remember this POP, persistent organic pollutant. It's not a good thing. So just talking a little bit more about these hydrocarbons. So I'm just showing you the structure of, yet again, a series of benzenated compounds now essentially bonded together. And again, those benzenated compounds cause a lot of problems. Okay, so I'm actually going to stop the video right there, and then I'll get more specific into specific types in the next video of hydrocarbons and how to name them specifically. This is just more of an introduction to the unit. Okay, see you on the next one.